So next one is the characteristic table of J and K. Here we are driving the and excitation table of your J and K flip flop. So these tables are to be important whenever we are doing the conversion of your flip flop. Then these two characteristics and excitation tables of your flip flops are to be very important. So here in the characteristic tables we having the one output, that is your qn plus 1, that is nothing but the next state, that is representing the next state. So here you can see that your next state, that is to be depending upon your present inputs. So your present inputs are nothing but j and k, and also depend upon your previous state, that is represented with your qn. So for this output of your qn plus 1, we having the three input variables j, k and your qn. So for the three input variables, we having the possibility of your 8 possible combinations. So here we are having the 8 possible combinations for your three input variables qn, j and k, and we having the one output, that is your qn plus 1. So we are driving this characteristics table of your j and k by using the truth table of your j and k. So the first case, you can see that is your qn is 0. Next one is your j is that is also 0, k is 0. So here you can see that just look at the truth table of your j and k. So here you can see that we are having your qn, that is 0, and j and k both are to be 0 and 0. So here you can say that this state j and k both are to be 0. So your qn plus 1 is nothing but your qn. So here is the qn is, that is 0. So the value for the first case, that is to be 0. The next case is your qn is 0, and j and k, that is your 0 and 1. So here you can say that in the truth table j and k, that is your 0 and 1. So the output is 0. So the output is 0. Third case, the jk is 1 and 0, and qn, that is also 0. So here is the third case, 1 and 0. So the output is 1. Next, the last case, that is your j and k both are the 1 1. So here you can see that the last case, that is your 1 and 1. So the qn plus 1 is nothing but the complement of your qn. So here you can see that the qn is now 0. So the complement of your qn, that is nothing but the 1. Next one is your 0 0. So whenever the 0 0, whenever both are the j and k are to be 0 0, the output of the next state, that is your the previous state, that is the 1. So that is 1 here, qn, that is 1, that is to be representing your previous state. Next is 0 1. So from the truth table of your jk, whenever your j is 0, k is 1, the qn plus 1, that is 0. For 1 and 0, this one is 1. For the last case, when both are j and k are to be 1 1, and this one is equal to your qn complement. So here is the qn is 1, so the complement of 1, that is to be 0. So this is the characteristic table of your j and k. Next, by using this characteristic table, we are obtaining your excitation table of your j and k. So for this one, we having the two input variables, that is your qn and your qn plus 1, and we having the output, whatever the inputs of your flip-flop, that is your j and k. So qn, that is to be representing your previous and the next state. So two input variables, so the possibility is that the possibility of your four possible combinations, that is 0 0 0 1 1 0 and 1 1. So the first case, whenever your qn, that is 0, qn plus 1, that is also 0. So here you can see that the qn is 0, qn plus 1 is 0, qn is 0. For these two cases, your qn and qn plus 1 is to be 0 0. So here you can see that your j is same, that is 0 and 0. So j is 0, but your k is changing from 0 to 1. So k is representing with your don't care condition, that is represented with this x variable. So x आपका 0 भी हो सकता है और 1 भी हो सकता है. Next qn, that is 0, and qn plus 1, that is 1. So this one is your 0 1 0 1. Next qn is 0, qn plus 1, that is 1. So in this case you can see that your j is same, that is 1, and k is changing from 0 to 1. So this one is represented with your don't care condition, that is x. Next आपके पास case है, that is your 1 0. So here you can see that qn is 1, qn is qn is 1, and your qn plus 1, that is 0, this case, and the last one is this case, these two cases. So in these two cases your qn is 1 and qn plus 1, that is to be 0. So here you can see that your k is same, that is 1 and 1, and j is changing from 0 to 1. So your j is represented with your don't care, and your k is, that is 1. And the last case you can see that where your qn and qn plus 1, that is your 1 1, here is qn is 1, qn plus 1, that is 1. Here is your qn, that is 1, and your qn plus 1, that is to be 1. So in this case you can here you can see that your k is same, that is 0 0, but your j is changing from 0 to 1. So for the j, this one is your don't care, and for the k, this one is your 0. So this one is the excitation table of your j and k, that is derived from your characteristic table of your j and k. So now by using your k map, just obtain the value of j and k by using your k map. Obtain the value of j and k. So दो inputs हैं, तो obviously you are using your 4 cell k map. 4 cells बनेंगे, 2 inputs हैं. Next by using your k map, just obtain this qn plus 1. ठीक है, 3 variables हैं, so possibilities of your 8 cells k map. So ये आपके लिए होमवर्क होगा. Just obtain this j and k from the excitation table by using k map, and from the characteristic table just obtain this qn plus 1 by using your k map. For this qn plus 1, you having the 3 input variables, that is qn, j and k. And from the excitation table, whenever you are obtaining this j and k by using k map, for the j you're having the 2 input variables, that is your qn and qn plus 1. For the k, same, qn and qn plus 1, 2 input variables. Just obtain this and drive the equations for qn plus 1, j and k by using your k map.